A stadium can hold 25,000 people. People attending a regular event at the stadium must purchase a ticket in advance. When the ticket price is €20, the expected attendance at an event is 12,000 people. The result of a survey carried out by the owners suggests that for every €1 reduction from €20 in the ticket price, the expected attendance would increase by 1,000 people. Okay, so here's the situation for a ticket that costs €20. The expected attendance is 12,000 people. So let's reduce this ticket price by €1 to €19. And the survey suggests that if we do that, the expected attendance would increase by 1,000 people. So now the attendance is 12,000 plus 1,000, which is 13,000. So if the price goes down, the attendance goes up, which is fairly intuitive. So let's look at a situation for €18. Well, that's a further euro reduction in the ticket price. The attendance goes up by 1,000 to 14,000. Let x be the ticket price where x is less than or equal to 20. Write down in terms of x the expected attendance at such an event. So these values are our x values. Okay, that's the ticket prices, and let's call these values our y values, the attendance that's expected for a given ticket price. So we want the relationship. Okay, so for any value x, what do we expect y to be? We could even imagine a graph. When x is 20, y is 12,000. So let's suppose this value is 20, and we go up to 12,000 on the y-axis. Of course, the scales are very different here on both x and y axes. I'm just showing a rough sketch. So this point has coordinates 20, 12,000. When x is 18, y is 14,000. So y is a higher value, the attendance is greater. Okay, again, this is just a very rough sketch, so we can forget about the scales on the x and y axes. Now, but what about the situation when y is 19? Well, that point is actually midway between these 2 points. Okay, as x decreases by 1 unit, y decreases by 1,000 units, and we could imagine making that scale finer and finer. We could imagine decreasing x by, say, 50 cent. Well, y would decrease by half of 1,000, or €500. Or sorry, y would increase by half of 1,000. Or 500 people, not euros. Okay, so we are assuming a linear relationship here, that the graph is a straight line. So basically, we want the equation of this line. Okay, x can be less than 18, but not greater than 20. So the line terminates at this point. So how do we get the equation of a line? Well, we get the slope of the line and pick any point on the line. Okay, so let's consider the slope of this line. Well, this distance here is the difference between the y values, 14,000 minus 12,000, that's 2,000. And the horizontal distance between the points is 20 minus 18, which is 2. So the slope m is minus 2,000 divided by 2. So we put rise over run, and we see that this line has a negative slope. It's sloping this way. So the slope is minus 1,000. And the equation of any line is y minus y1 equals m times x minus x1. So let's use this point here. So y1 is 12,000. So y minus 12,000 is m, which is minus 1,000, multiplied by x minus x1. So x1 is 20. Of course, we can use any point on the line to get the equation of the line. So I've multiplied in here by minus 1,000. If we add 12,000 to both sides, we get the relationship between attendance and ticket price. Next, we want a function f that gives the expected income from the sale of tickets for such an event. So f stands for the sale of tickets. Okay, so this is our attendance. So we have to multiply the attendance, that's the number of people that attend, of course, by the price per ticket, the cost of each ticket, which is x. X stands for the ticket price. So we have to multiply this thing by x. Okay, so we see that this is a quadratic function in x. We get minus 1000x squared plus 32,000x. Okay, let's look at a graph of this function. So f is the expected income and x is the price of each ticket. Now, if it's a quadratic function, its shape is a parabola. And since the x squared term is negative, we have an inverted parabola. What about the intercept on the f-axis? Well, you can see that the constant term in this quadratic is 0. So this curve goes through the origin. Okay, when x is 0, f is 0. So we'll just use that one point to draw a rough sketch. So it's going to be an inverted parabola, so it's going to look something, well, not like that, of course. It's a parabola, it's symmetrical. So we want the price at which tickets should be sold to give the maximum expected income. So we want the x value of this point. Okay, this will be the price that maximizes f. F is the income. Now there are two ways that we could do this. We could use differentiation, or we could find where the graph crosses the x-axis and get the midpoint of those 2 points. And that point will be the x value that we're looking for. So I'll do it both ways. First of all, I'll solve the equation f equals 0, f of x equals 0, to find where the graph crosses the x-axis. Okay, the value of x that makes f 0 is the x value of each of these points. Okay, f is 0 for these 2 points. So set this equal to 0. Very easy to solve this quadratic equation because there's no constant term. That's the beauty of it. We can just factorize x out of it. We can actually divide everything by 1000 to make things easier. So we get minus x squared plus 32x equals 0. Factorize x out of this. Okay, the factors are particularly simple when there's no constant term, or when the constant term is 0, we could say. You could use your minus b formula, of course, but c would equal 0. But this is much quicker. Very easy to get the factors. One of the factors is just x. We just pull out x out of this expression. Next we set both of these factors equal to 0. So if we set x equal to 0, we get one solution. And if we set the other factor equal to 0, we get minus x plus 32 equals 0, or x equals 32. Okay, so if the product of two things is 0, then either of them, or both of them, must be 0. So this value is 0, as we know, and this value here is 32. So this value is midway between 0 and 32. 32 plus 0 divided by 2 is 16. Okay, let's repeat this question using differentiation. At this point, the slope of the curve is 0. The curve is neither increasing nor decreasing. The slope of the curve is the derivative. Okay, so the slope of the curve at x, well, it's the slope of the tangent, which is 0. The tangent is horizontal. And we want to set this equal to 0. If we differentiate this thing here, what do we get? We get minus 2000x plus 32,000. Set it equal to 0 and solve. So again, we get minus 32,000 divided by minus 2,000. That's 16. Okay. Now we want to find the maximum expected income. So when the ticket price is 16 euros, the income is a maximum. So what is that maximum? We want the coordinates of this point. So we have the x coordinate. We want to find the f, or the y coordinate. It's the f coordinate in this case. So we just plug 16 into the expression, that gives us the curve. So we get f of 16 basically. So that's minus 1,000 times 16 squared plus 32,000 multiplied by 16. So we get 256,000 euros. Suppose that tickets are instead priced at a value that is expected to give a full attendance at the stadium. So what is full attendance? Well, if you read back through the question, full attendance is 25,000 people. Well, from a previous part, here is the expression that gives us what's this? This is the attendance when the ticket price is X euros. And we want the attendance to be 25,000. So we just solve this. So subtract 32,000 from both sides and divide by minus 1,000. So that's going to give you minus 7,000 divided by minus 1,000. So that's going to give us 7 euros. So when the ticket price is 7 euros, the expected attendance is 25,000 people. So that will fill that number. That's the maximum number that the stadium can hold. So what's the income? Okay, so we have the price per ticket. Well, the attendance is 25,000, so the income is got by multiplying the number of people, 25,000, by the price per ticket. 7 times 25,000. So we get 175,000. Now we want the difference between the income from the sale of tickets at this price, that is at 7 euros, difference between 175,000 and the maximum income that we saw in the previous part. So here is the maximum income that occurred when the ticket price was 16 euros. And we want to subtract this value here. The stadium was full for a recent special event. 2 types of tickets were sold. A single ticket for 16 euros and a family ticket for a certain amount. The income for this event was 365,000 euros. Now I will let P stand for the number of single tickets sold. Okay, so we are not told how many single tickets were sold. Well, we can get the cost in terms of P, of course, because the cost of a single ticket is 16 euros. So we just multiply P by 16, or 16P. That's the cost of all the single tickets. Now we are not told how much a family ticket is, so I let Y euros stand for the price of a family ticket. Now, how many family tickets were sold? Well, we could say that X family tickets were sold, and we'd multiply X by the cost of a family ticket, X times Y. But actually X and P are related, because we are given that the stadium was full. Okay, so we know how many tickets were sold in total. The stadium was full, 25,000 tickets were sold. Well, 25,000 people filled the stadium. So if P single tickets were sold, how many people are left over? Well, we just take the total number of people, which is 25,000, and subtract P. So P is the number of single tickets, which are just individuals, of course. Okay, so this expression gives us the number of people that are left over after all the single tickets have been sold. So all these people that are left over bought family tickets, but a family consists of 2 adults and 2 children. So we need to divide this quantity by 4 to get the number of family tickets sold. Okay, so these are just single people. There are 25,000 minus P single people left, but they all bought family tickets. Well, they didn't all individually buy family tickets, but that those are the groupings that are left. Okay, families, and each family has size 4, so we need to divide this down by the size of each group. So we divide this down by 4. So this expression gives us the number of family tickets sold. So again, this expression gives us the number of groups of 4 people that make up the remainder of the stadium. Okay, so that's P single people removed, and these are the number of groups of 4. So we're talking about families here of size 4. So there's a ticket for each family. Now let's consider the income. So as before, we saw that for the single tickets, each one is 16 euros. So if P of them are sold, we P times 16 or 16 P euros income from the single tickets. And now we have to consider the income from the family tickets. So we have to take the number of family tickets, this expression here, and multiply it by the price of a family ticket. Now that price we don't know. I'm just calling it Y. But anyway, the total income is given to us. It's 365,000. You can see here that we have an equation with 2 unknowns, P and Y. So obviously we cannot solve this equation. We need some more information to find out what P and Y are. So the next part of the question gives us that extra information. If 1,000 more family tickets had been sold, right, so how do we work that into an equation? 1,000 more family tickets had been sold. Well, we'd add 1,000 onto this expression here. Okay, so we would be adding 1,000 onto this, but that's going to affect the number of single tickets sold. Because remember, the stadium can only hold 25,000 people, so this is the constraint. We cannot change this figure. So if the number of family tickets goes up, the number of single tickets must go down. Okay, so here I'm writing down the income from the family tickets. So this is the new income from the family tickets. So in brackets is the number of family tickets sold. That's the old expression, plus 1,000. But we have to multiply it by Y. Y is the price of a family ticket, so apparently that hasn't changed. Well, we are not told that the price of a family ticket has changed. It's still Y euros, whatever Y is. Okay, so we have 1,000 extra family tickets, but how many people does that represent? Well, a family consists of 4 people, 2 adults and 2 children. So we are talking about an extra 4,000 people catered for. So there's an extra 4,000 people in this expression. Okay, 1,000 family tickets corresponds to 1,000 times 4, or 4,000 people, where the people are, well, each grouping is 2 adults and 2 children. Okay, half of them are actually adults. 2,000 will be adults and 2,000 will be children. P is the number of single tickets, so the number of single tickets must decrease by 4,000. So the number of single tickets is P minus 4,000. And to get the income from those single tickets, we must multiply by the cost of a single ticket, which is 16 euros, just like before. That hasn't changed. So the total income is got by adding these two together. And what is the total income? We are told that the income from the event would be reduced by 14,000. So we just reduce this number by 14,000. So now we have a second equation in the 2 unknowns P and Y. So we should be able to solve between these 2 equations to find out what P and Y are. Now, by the way, these are not linear equations in P and Y because we have a product P times Y here. You see, if we multiply Y by this expression, we get 25,000 Y minus P times Y. So this equation is non-linear. It's not a line because of the product P times Y appearing. Okay, for a linear equation in P and Y, they would have to form a constant times P plus another constant times Y equals another constant. Like, it would have to have something like this form. Okay, A, B and C would have to be numbers, but that's not the situation. So it looks like this is difficult. It looks like we have to make P the subject of one equation and plug that expression into the second equation. Get P in terms of Y, say, for the first equation, plug the result into this equation and solve for y. That's one way we could do it. Or of course we could get y in terms of p and inside the first equation and plug into the second equation to get an equation in p only and solve for p. But fortunately, if you look at these terms, we can combine both sides of this equation in such a way that we cancel 16p, and we also end up cancelling all of this term here, this times y. So we end up basically with an equation in y. We will end up cancelling the p terms and the term that has py in it, that non-linear term. So just to make things clear, I'll just write this out again. As a matter of fact, what I could do is just write out the second one. I'll just change its form so you can see it even more clearly. So we've 16p times p minus 4000. Well, that's just 16p minus 16 times 4000. That's minus 64,000. Okay, and we can multiply y into this thing. I could actually just put this expression times y plus 1000y here. Now we can take the left hand side of the top equation and subtract the left hand side of the bottom equation. So we'll have 16p minus 16p. That's going to give us 0. And then we have we'll essentially have we'll be subtracting this from what's on top, so we can imagine 0 minus this term. Well, so that's going to give us plus 64,000 here. Okay, so imagine taking the left hand side and subtracting all of this. We would be minusing all of this expression. So we'd end up at plus 64,000 here. We would be taking this, all of this thing here, this complicated looking thing, and subtracting this thing from it. So they'll cancel out, which is very convenient. And finally we would be subtracting this here. And now we take these numbers and subtract. Well, this was a decrease of 14,000, so we know what this is. So we have a very simple linear equation to solve. We subtract 64,000 from both sides to get minus 50,000. Divide both sides by minus 1,000 to get 50. So we found the price of a family ticket. It's 50 euros. Now let's find p. Okay, so that's straightforward. We just substitute this value into one of these two equations. So I'll substitute into the top equation. So we'll have 50 times this expression here. Alright, so I've multiplied 50 by 25,000, and 50 times minus p, we have to divide by 4, and we need to solve this equation for p. Now minus 50 divided by 4 is minus 12.5 p, plus 16p. 16 minus 12.5 is 3.5, so we get 3.5p, and I'll take this number, subtract it from both sides. So you'll end up getting p equals 15,000. So what is p again? P is the number of single tickets. Okay, as an aside, I will just run all these numbers forward just to see that everything makes sense. So 15,000 single tickets were sold. The cost of a single ticket is 16 euros. So we'll take the first situation here. So the total cost is going to be 16 multiplied by 15,000. Well, this is the income from all the single tickets. A family ticket is 50 euros. So how many families were sold tickets? Well, the total number of people is 25,000. We have 25,000 people in total minus 15,000 single people. So that's 10,000. So the remaining 10,000 people are families, okay? And the family has size 4, 2 plus 2. So we divide 10,000 by 4 to get the number of family tickets. 10,000 divided by 4 is 2,500. So 2,500 family tickets were sold at 50 euros each. So if we work this out, we should get 365,000. Okay, that checks out. Now if 1,000 more family tickets had been sold, well, let's just take this statement. So initially that's the number. In the first situation, that's the number of family tickets that were sold. 1,000 more would mean 3,500 family tickets being sold at €50 each. And what's the situation with single tickets? Okay, so 1,000 more families means 4,000 fewer people, fewer single tickets. So it's 16 multiplied by 15,000 minus 4, which is 11,000. Okay, so this cost, the total income in this situation, should be €14,000 less than the previous situation. Okay, that also checks out. We get this value, which is 365,000 minus 14,000.